So today we're going to talk about writing the equation for a line given information other than just a slope and a y-intercept. Like we've done it before where I give you an m and a b and you just have to put them in the right places in the equation for a line. Okay? But today we're going to be looking at a bunch of different combinations of things. And so one of the things we need to talk about is what happens if I give you a slope and then a point that's not necessarily the y-intercept. Okay, because you can't just throw that into the equation. So let's do a quick example of that. And there's two methods here, so you might kind of want to split your paper down the middle, and I'll show you both methods, and then you can kind of decide which one you like better.
I have a question.
Sure, go ahead.
This is when you just like start with the point and then you do the slope and whatever goes through that.
So you could do that, yeah. So what Haley's saying is, couldn't you just start at whatever point you're given and then kind of work from your slope backwards until you find the y-intercept? Yeah, you could. The problem is sometimes you won't land directly on the y-axis. Sometimes it's going to be like halfway between or something like that. But that's certainly a good kind of problem-solving strategy. So let's say I tell you that the slope is 3, let's just say, and that the point I'm giving you, it goes through the point, let's say 4, 1. Okay. This method is probably the one that I think is most popular with students, especially since it's close to what we did when we solved for the k value back in chapter 2. We know that our equation is going to look like this, right? Y equals mx plus b. And we know that this 3 is going to go in place of m, right? But we don't know what b is the problem. Any thoughts about something I could do to find out what b is? Sylvia?
You take 3 times by 1 and then minus it from 4 and then get
Okay.
1.
So really what Silvio is doing there is he's plugging in the 4 and the 1 for x and y. Okay, so normally in our equation we don't want numbers in where x and y are, but we can use those numbers to solve for b. So I'm going to plug this in for x and this in for y just kind of temporarily. So I'm going to say, let's see, my y is 1. And I think you were a little backwards in what you said, but you had the right idea. That's okay. So m is 3, x is 4, and then b is what we're trying to find. Well, this is really a 12, right? So now we have 1 equals 12 plus b. And then to solve for b, I can subtract 12. Jumping ahead there a little bit. And I end up with negative 11 equals b. So now when I go to write my equation is going to be mx plus b. What was my m again? 3. So 3x. And then I just found that b was negative 11. And that's my equation. Yeah. Okay. I mean, you could do it that way, but So really what you're doing here is you're starting with that frame of mx plus b. You're plugging in your slope, and then you have a coordinate, so you can plug that in for y and x to find your b value. You just want to make sure when you write your final equation that you pull that coordinate back out, because the 4 and the 1, you don't want to leave those as part of your equation like forever. Good? Feel okay about that? Okay. So let's try that same thing using a different method. So I'm going to stick with those same two things. So m equals 3, and we're going to go through the point 4, 1. And this method is using a formula called point slope form. So with this method, you do have to have a formula memorized. And here's what that formula looks like. Y minus y1 equals m times x minus x1. Okay, so this right here is what's called point slope form. And in that form, the x and the y, the regular x and y, still stay x and y. And then where you see the x1 and the y1, that represents a coordinate of any point on the line. So x1, y1, that would be my 4 and my 1. And then m, that's my slope. I already know that. And so I would set this up like this. Y minus 1, because that's my y1, equals m times x minus x1, which is 4. Everyone okay with where those numbers all came from? Give you a second to catch up on writing. I know I just wrote down a lot there for you. And remember, our goal is to get it to look like this. Okay? So what could we do with this now that could eventually make it look like that? Okay, we could distribute. Basically, we're simplifying, right? So I could take this 3 and distribute it. So y minus 1 equals 3x minus 12. And then, remember, my goal is to get y by itself. So what number would I want to move now? The 1, right? So I would add the 1 to the other side. This is gone. And so I end up with y equals 3x minus 11. Because negative 12 plus 1 is negative 11. So I end up with the same thing. I showed you both of these methods because your book goes about it this way. So anything you look at in the book is going to look like this. All right? This is the way I had always learned it. And honestly, I didn't even learn this equation until I started teaching this class because I had always just done it this way. Either way is fine. Okay? Either method will work just fine, whichever one you like better. All right, Gabe?
Which one do you think takes less time? And if you were to do it like the ones you use?
I think really if I were doing it on my own, I could do either one in about the same amount of time. The only downside I see to this one is that you do have to memorize that formula. So if you don't know that formula well and you have to like look it up every time, that's going to take you a little more time. The math though, like this math compared to this math, it's about the same complexity-wise. Okay? How many of you feel like just right now you like method 1 better? The first one. Okay, you've seen the other one before. How many of you like method 2? And that's total. Okay, so I was just curious. Whichever one you prefer is good with me. Okay, so now that we've kind of looked at that method, I want to talk about in general, what do we need to be able to write the equation for a line? Well, what 2 pieces do we need if we're going to use mx plus b? Slope and y-intercept, right? So down here, we're going to just write slope and y-intercept. Okay, those are the 2 things we need to kind of keep our focus on anytime I'm asked to write an equation for a line. Okay? The slope can be given to you lots of different ways. Okay, so sometimes it just gives you a slope. Sometimes it just says the slope is, like that problem we just did, it was just given to you, right? What if I give you 2 coordinates? Well, kind of. What do you have to, so instead of me giving you, like, for example, in this problem, instead of me saying the slope was equal to 3, what if I said it goes through this point and then gave you a second point? Say it again, Francis? How so? Okay, rate of change formula, right? The y2 minus y1. So yeah, it's not difficult to come up with, but if I give you 2 coordinates, we would do y2 minus y1 over x2 minus x1. Okay. Trying to think of what other ways it also shows up. Sometimes it'll say it's parallel to a given line. And we've already looked at some of those too, right? So if it's parallel to a given line, you just keep the same slope as the line that you're given. If it gives you a perpendicular line, yep. Opposite reciprocal. And I think that's about it. There's some kind of weird ones that we're going to talk about in just a minute, but in general, all of these problems will fall into one of those categories. Either it'll just hand you the slope, or it'll give you some coordinates you can work with to find the slope, or it'll give you like a parallel or perpendicular line and you can take the slope from it that way. Okay? Questions on any of those? Okay, for the y-intercept, it's either going to just be given, so it'll tell you what the y-intercept is, or if not given, we're going to solve for b. And you can solve for b either one of the two methods up above. So let me just write down that that's what we did up above, is learned how to solve for b. Okay, so the two methods that we talked about above, that's what you do when you don't have the y-intercept. Okay? And again, this is all just general right now. We're going to dive into some examples in just a minute. But there are some unique ones that kind of show up once in a while. I'm going to kind of just write these down at the bottom. That would be your horizontal and vertical lines. What does the equation look like for a horizontal line? Y equals a number, right? Okay, so y equals a number. And then we also know that with this type of equation, my slope is 0. So if it says, write me an equation for a horizontal line that goes through such and such point or whatever, you know that your equation is going to look like this. Or if it tells me you have a slope of 0, write me an equation, you know your line's going to look like this. Okay? So both of these pieces of information go with the y equals a number type equation. And then vertical line is the same thing except it's x equals a number. An undefined slope, yep. And I guess I probably should have put these arrows going the other way. Because kind of our goal is always going to be to get to the actual equation, which are those things in the middle. So sometimes it'll say, this is a horizontal line, this is a vertical line. Sometimes it'll say you have a slope of 0, you have an undefined slope. And you have to know where those equations come from. So this is kind of your roadmap, all right? This is kind of your general thing that you fall back on when you're looking at these examples. Because if you look at like the next page where all the examples are, every single example is different. There's not a way that I can possibly go through one of every type of problem I could ever throw at you, okay? So it is going to be important that you have kind of some generalized strategies. It's not just a every problem looks the same kind of thing, okay? Everyone good with that up to there? Can I pull this off? Anyone still writing? Okay, so let's look at some examples. So right out of the gate there, I've got two coordinates, 6, 4, and 2, 8. Is that the first example you have also? Yes. Okay, because I feel like I did some revisions and I want to make sure I printed the right one. So, okay, so our first step is we need our slope, right? We always start with our slope. How are we going to find slope in this situation? If you have two coordinates, Sylvia, go ahead. Rate of change, right? So I'm going to go 8 minus 4 over 2 minus 6. So that was y2 minus y1 over x2 minus x1. That gives me 4 over negative 4, which is negative 1. So I know now my slope is negative 1. Do I have my y-intercept? No. Okay, so this is where I plug in and solve for b. And I'm going to do this one with method 1. Maybe I'll use method 2 later on just so I can kind of show you both. But so using method 1 to get my y-intercept, I know my equation is going to look like this. Y equals mx plus b. This is going to be my m. right? And then I need to plug in something for x and y. Does it matter which one of these I pick? It doesn't actually matter. I can use either one. I just have to stick with one. I can't use like the x from one and the y from another. I don't know why you would ever do that, but should just point that out. So I'm going to just go with 6 and 4. Okay, I'm going to plug these in as my x and my y for a second. And so I'm going to go 4 equals, my slope I said was -1 times 6 plus b. That gives me -6 plus b. And then I'm going to add 6 to both sides. And I come out with +10 for my b value. And so now I have an m, I have a b, and now I can write my final equation as -1x plus 10. How do we do? Feel okay about that? Yeah. Okay. Let's see. I'm going to skip example 2 for just a second. I'm going to come back to that at the end. There's a piece of example 2 that actually comes from lesson 3-4, but because we skipped over 3-4, we kind of missed that. So I'm going to do a couple other examples, probably not all of these. And then I'll circle back to example 2 and give you just kind of a preview of something you'll be seeing tomorrow. Okay? So look at example 3. Horizontal line containing 6, -1. As soon as you see this, I want a red flag to be jumping into your mind here. Horizontal line. What do we know this equation is going to look like? It's y equals a number, right? If it's horizontal, it's y equals a number. I want that to jump into your head right away and for you to kind of throw out everything else, because when it's a horizontal or a vertical line, we don't have to worry about doing any of that other junk, right? I just know that my equation is going to be y equals something. Now, if I have this coordinate on my line, what do I know my y is always going to have to equal? -1. Yeah, because in that coordinate, my y is -1. And in this type of equation, my y values are always going to be the same. So if that coordinate's on my line, my y's must all be -1. Okay? If this had said vertical line, then I would have gone with x equals, and I would have said x equals 6. Does that make sense? Feel okay about that? All right, look at number 4. X-intercept of 5, Y-intercept of -8. So this one's kind of nice in that I have a Y-intercept here, right? I'm not going to have to work for that. How can I get slope from that, though? Any thoughts, Gabe?
You find your own points.
Okay, find my own points. How?
Using the x-intercept and the y-intercept and then graphing it.
Okay, so we technically could. We could graph it and find some other points. Aren't the x and the y-intercept themselves points, though?
Yeah.
Right? So, yeah, we can turn these into coordinates. My x-intercept of 5, that's really going to be 5, 0. Okay? Because at the x-intercept, your y value is always equal to 0. Okay? And notice that the x-intercept of 5, make sure the 5 goes in the x spot. What's the coordinate going to look like for the y-intercept then? Yep, 0, -8. So the x-intercept, make sure the number goes in for x. The y-intercept, make sure it goes in for y. And then I can do my y2 minus y1 thing, right? So I can do -8 minus 0 over 0 minus 5. Okay? Let's see, that's going to give me -8 over -5. Which is kind of ugly. I wouldn't actually divide that, but I would drop the negatives off of there. So I know that my slope is 8 over 5. What do I do to get my y-intercept? Say it again, Zoe. Okay, so like into the equation, you mean? Okay, we absolutely could. You could go with mx plus b. You could plug in, 0 for... Oh, I see what you're saying. The y-intercept sitting right there for me. You're right. Sorry. Misunderstood you there. Yeah, my y-intercept is right here. I already know what my y-intercept is. So my slope is 8 over 5. And so I can just go 8 over 5 x minus 8. There we go. Good with that? Questions there? Okay, let's try one more because I want to practice some perpendicular lines. We haven't done very many of those. So let's try a perpendicular line. So first step, finding my slope. The slope of this line is 2/3. Is that what the slope of my line is going to be? No, what do I have to do to it? Okay, so I'm going to go 2/3. I'm going to actually turn that into a negative 3 over 2. And that's because I wanted a perpendicular line. Okay, so the negative 3 over 2 is going to make my line be perpendicular. Now from here, this one happened to give me my y-intercept, right? So again, I wouldn't have to work too hard here. If this was a question, though, where it said, you know, here's a perpendicular line and I want it to go through this point, then you wouldn't be able to just jump directly to the equation. However, the fact that this gives me the y-intercept right away makes this easy for me. What's my equation going to be? Can someone raise a hand and tell me? What's my equation going to look like? Go ahead, Gabe.
Y equals negative 3 over 2x plus 0.
Yep. And yeah, so I'm going to write that in there just so we know where that came from. But technically, you could get away with not putting the 0 on there because adding 0 doesn't really do anything. You could just say y equals negative 3 halves x. Okay?
So if it's plus 0 and it has that x, that means I don't have a, like, the slope won't be 0. But if it does,
Right.
if it's just y equals negative 3 over 2, then it's...
Exactly. Yep. So this, y equals negative 3 halves x, that's still going to be like a diagonal line. That's just going to go through the point 0, 0. But it'll still have a slope. It'll still have rise and run. Okay? If it didn't have an x on it, if it was just y equals negative 3 halves x, y equals negative 3 halves, that would just be a horizontal line. And I didn't know if we'd get through all of them, but number 6 is actually really easy, so let's just do that quick. Undefined slope. What's jumping into your mind right now? It's x equals, right? Undefined slope, as soon as you see that, be thinking of your vertical line, right? And so we know that's x equals something. And just like up in number 3, I can just pull that right out of my coordinate, except this time I'm looking for the x number instead of the y. So my equation here would just be x equals 4. Okay? Not terrible, right? Okay, so let me just, I'm going to look back up at example 2, and I want to go through something that is technically part of tomorrow's lesson, but